Hello dear students, let's go for the next part of the Laplace transform is Laplace transform of periodic function. Let us have the definition. A function f of t is said to be a periodic function of period t greater than 0 if f of t plus nt is equals to f of t, where n is equals to 1, 2, 3 and so on. Means if you want to say a function is a periodic function, it should, if you want to say a function is a periodic function, it should contain a period t greater than 0. Then you can say a function is a periodic function. You can see example here. Sin t plus 2n pi is equals to sin t. Cos of t plus 2n pi is equals to cos t. It means cos t and sin t are the periodic function with the period 2 pi. This cos t and sin t have a period 2 pi. Therefore, these are called the periodic functions. Okay, there is a theorem on periodic function. If f of t is a periodic function of period t, then L of f of t is equals to 1 upon 1 minus e raised to minus st integration 0 to t e raised to minus st f of t dt. L of f of t is equals to 1 upon 1 minus e raised to minus st integration 0 to t e raised to minus st f of t into dt. This is a theorem. Okay, using this theorem, we are solving the problems. Okay, let's go for the problem. If f of t is equals to t square, here period is given 0 less than t less than 2, and f of t plus 2 is equals to f of t for t greater than 2. For t greater than 2, find L of f of t. Just have a look on a function f of t is equals to t square. If it is given only this term f of t equals to t square, excluding this term, this is just like a common function t raised to n. It is just like a common function t raised to n. Then the Laplace transform of t raised to n is n factorial upon s raised to n plus 1. But this is a periodic function here given with the period 2. With the period 2 here they are given. We need to use a theorem. Using that theorem, we need to find the Laplace transform of this function. F of t is a periodic function of period 2. That is t is equals to 2 here. We have a theorem L of f of t is equals to 1 upon 1 minus e raised to minus st integration 0 to t e raised to minus st f of t into dt. Okay, here t equals to 2 is given. Substituting that one, L of f of t is equals to 1 upon 1 minus e raised to minus 2s integration 0 to 2 e raised to minus st, and function f of t is nothing but t square into dt. 1 upon 1 minus e raised to minus 2s integration 0 to 2 t square e raised to minus st. That is this term I just rewritten into b. I just written it as b into a, like that. Now we need to integrate the term t square e raised to minus st. By applying Bernoulli's rule of integration by parts, we will integrate this term. L of f of t is equals to 1 upon 1 minus e raised to minus 2s into bracket t square into e raised to minus st upon minus s between the limits 0 to 2 minus 2t into e raised to minus st upon s square between the limits 0 to 2 plus 2 into e raised to minus st upon minus s cube between the limits 0 to 2. Means this is the Bernoulli's rule of integration, that is u into v, integration of u into v dt is equals to u into integration of v dt minus u dash, that is derivative of u, into double integration of v with respect to t plus u double dash, means second derivative of u with respect to triple integration of v into triple integration of v with respect to t and so on. This is the Bernoulli's rule. Using this Bernoulli's rule, we are integrating the term t square e raised to minus st. Here u is t square, v is e raised to minus st. Using Bernoulli's rule, here we have integrated this term. Next, here we are substituting the limits. Upper limit to lower limit 0. Upper limit to lower limit 0. 1 upon 1 minus e raised to minus 2s outside the bracket, minus 1 by s. From this term I just taken out minus 1 by s. I am just substituting the limit wherever t is there. Substituting t is equals to t square, that is 2 square. 2 square is 4 into e raised to minus 2s, minus here t equals to 0. If you put second limit t equals to 0, the whole term becomes 0. Next, go for the second term. 2 by s square just taken outside. Next, remaining term is t into e raised to minus st. T into e raised to minus st, applying the limit, upper limit to lower limit 0. Here t is equals to 2 into e raised to minus 2s minus, here again t is there. Substituting t equals to 0, we have obtained that term is 0 only. Next, taking 2 by minus s cube outside the terms, left with e raised to minus st. Substitute the limit, upper limit to lower limit 0. Okay. E raised to minus 2s minus e raised to minus s into 0, that is e raised to 0. E raised to 0 is 1. Therefore, we have obtained the term 1 upon 1 minus e raised to minus 2s into bracket minus 1 by 4 into e raised to minus 2s minus 0 minus 2 by s square into 2 into e raised to minus 2s minus 0 minus 2 by s cube into bracket e raised to minus 2s. Next, 1 upon 1 minus e raised to minus 2s into bracket minus 1 by s into 4 I just written as 2 into 2 e raised to minus 2s minus 2 by s square into bracket 2 into e raised to minus 2s minus 2 by s cube into bracket e raised to minus 2s minus 1. Next, taking 2 by s cube from these bracket terms, that is 2 by s cube into bracket 1 minus e raised to minus 2s. Next, inside the bracket we are left with minus 2 e raised to minus 2s and one more term s square is. This is nothing but here we have in the denominator s, but we have taken s cube. Therefore, I have multiplied s square to the numerator of first term. Therefore, it is minus 2 s square into e raised to s minus, here in the denominator s square is there, but I have taken s cube. Therefore, multiplying s to the numerator, minus 2s into e raised to minus 2s. Next, you can see here it is 2 by s cube only. Just I have taken 2 by s cube. Therefore, minus e raised to minus 2s, minus into minus plus 1. Next, again rewriting this step, we have obtained the Laplace transform of a given function. L of f of t is equals to 2 upon s cube into bracket 1 minus e raised to minus 2s into bracket 1 minus, next taking e raised to minus 2s common from these terms, that is 2s square plus 2s plus 1 into e raised to minus 2s. This is the Laplace transform of a function t square with the period